Hey guys, another video for you. Now we're going to talk a little bit about pipeline processing. In recent screencasts we've talked about how we take events in, how we decide what stream they go into, and then how do we decide when a stream is ready for processing. So in this video what we're going to do is we're going to talk about the processing phase. The stream is ready and now we want to do some work on it. This is really the meat of the operation here. This is when we're taking all these events and boiling them down to get some salient piece of information, or we're trying to extract some business value out of our event stream. In previous videos I showed you the Oahu callback mechanism, where when a stream gets processed, a callback is called and you do some work. And in those examples I basically just showed like a print statement or anything or something like that. But the value of doing stream processing is that these operations have to be idempotent. If we do some unit of work and then something fails, we don't want to redo that work over and over again. So in a recent branch we added proper idempotent pipeline processing. So now what you can do is when you define your streams, you can pass in a list of handlers or a list of callbacks that you want to get called when a pipeline is ready or when a stream is ready. And we've broken the callback into two phases. One is the on-trigger call, which says do some stuff, and then the commit call. And the commit call is done when all of the handlers have been called and they've got their work staged and ready for final commitment. That way, if we run through all the handlers and something fails, something throws an exception, something bombs, then we haven't actually published anything yet. So we haven't updated the database, we haven't sent an email, we haven't issued an alarm. And that way we can go back and just mark the stream as being in an error state. We can go back and reset it later and let the processing resume again and not worry about getting flooded with emails. So now it's a two-phase operation, and so this slide is basically just showing how that operation works. So let's say we have some stream here and it's got a series of events in it, and now we want to do some processing on it. So what we do is we create a scratchpad object, and right now the scratchpad is just a dictionary that you can stuff what you want into it, and you have defined a list of handlers that you want to do the work for you on the pipeline. The first thing that'll happen is the on-trigger method in each of those callbacks will get called, and the same scratchpad will be passed into each of them. So this handler can do some work on the event stream and stuff its results in the scratchpad. And then the next handler will get called. The on-trigger method will get called. It'll have the same scratchpad. It can use those contents if they're available, if it knows about them, or it can just stuff its results in there as well. And then the next one will go, and the next one will go, and the next one. You can make this as long as you want. And if they all pass, that means that nothing throws an exception along the way, then we go back and we call the commit operation in each handler. And the scratchpad is passed in it as well. So now the on-trigger stuff sets up the data, stores it in the scratchpad. The commit thing actually does the work, the stuff that we only want to make sure happens once. If the on-trigger, any of the on-trigger calls fail, the stream will go into an error state. If any of the commit calls fail, it'll go into a commit error state. And they're both error states obviously, but at least then we can differentiate and find out what went wrong. And we will get a stack trace and some other information that we can work with. So that will result in essentially an idempotent operation. There is still a chance that if this commit message or this commit call fails, that we've done the work here, we've done the work here. So we could fall back and get the same. We could get the same email sent, or we could get the same alarm generated here. But ideally, what we want to do when we're not doing this right now is we want to save this scratchpad. So down here we would persist the scratchpad, or in between each step we would persist the scratchpad. So that if we came back around again, we could see, oh, you know what, we did this one already, let's skip it on the subsequent call through. We did this one already and store that in the scratchpad. We're not doing that right now, but that will come in a subsequent patch. But for now, what we have is stage all the work, and then issue all the work and use the scratchpad for it. So it's basically going to be the same operation. So let's see how that works in practice. Let's go back to our environment here, and this is again our config setup. I just showed you this in a previous screencast. We have our matching criteria, we have our triggering criteria, and then we have our list of callbacks. So for this particular trigger definition, we just have one callback, which is a request ID callback. Okay, so the request ID callback is defined right here, and it's just this object, request ID callback. And then for our end of day exists trigger definition, we've got the end of day exists callback, which is defined right here. So let's just go up and look at these. So the request ID one is taking a stream of all common or all related request IDs. And then at the end of it, what we do is we see how long it took from the first event to the last event. We calculate a time delta, and in the scratchpad we say for this request ID, this is our request ID, here's the time difference between the two of them. Very simple operation. Actually a very common operation. This is probably going to be one of the most popular pipelines that you're going to see in StackTach.v3. And then when we get down to the commit stage, we just print out a statement that says this request was this operation and it took this long to do. This is an interesting one here actually. So here's how we're determining what the operation was. Really, we should really fix this in Nova, but we look through the event types and we see if it's one of these things. So the first one that we find that is in this list of operations, the very first one that we know about, we go, oh, that's it, that's the operation that we're trying to do. And we've just got a list up here of all the popular operations, right? Instance shutdown, instance delete, instance or snapshot create, you know, all that sort of stuff. So that's how we determine which sort of operation that we're trying to determine, and we'll see this spit out here. Now we can do a lot of different things with this if we wanted to. We can get fancy with it and generate a new event from it that people could use for other operations. We could store it in a database. We could send it into, you know, generate a metric from it if we want to. Pass it into Manaska. Now this one down here, because I also want to show how the debugger works with this as well, because debugging pipeline processing is tricky as well. So in the onTrigger callback here, what I'm doing is I've got a random choice, true or false, which means a 50-50 chance that this thing is going to die. In this case, we'll generate an exception and say we had a trigger exception with some random number. And then in the commit phase, same thing, 50-50 chance it's going to fail, and we'll generate this message that says commit exception. Because if one of these things is failing, we want to find out why. We don't want to have to pour through log files. So the debugger is integrated with the callback pipeline, so we can easily find out what's happening. Okay, so those are our two callback definitions. You'll see before, previously all we had was just an onTrigger call. Now we have onTrigger and commit as our two steps. Okay, so let's see this thing working here. Okay, so we're going to run the sandbox again. It'll generate a bunch of events, fire it through, and just like we've shown in other videos, the pipelines will all get processed. So now we've sent the events in. We'll give it a second for all of them to go through. We can just look at this here. So this is the worker for streams that are ready for processing, and we've got two of these workers going. So we're looking for streams that have triggered and are ready to do something interesting. So I'll just pop back and forth between window 3 and window 4 here until something happens. So we're polling every 20 seconds here. And here we go. So now we're starting to see some of the end of day exists ones come through. Right? And remember what we said, that was that we were going to output the name of the stream and the trigger definition. That's really all that thing did. But now we've got some debug information that came out here. So we processed out of a block of 100 streams. We got 9 of them. We processed them. 6 of them were locked, which means the other worker got it. But for the end of day exists trigger definition, 4 of them failed with onTrigger errors, and 2 of them failed with onCommit errors, because we always said it was a 50-50 chance this was going to happen. And so now we're seeing this output. So we're processing it, and this failed, and then that one failed. So so now we would go back and we would look and find out, what failed in here, what the exception was, and we'll show you that in a subsequent video. Okay, so now we just had a whole ream of them come through for our request IDs. Now these ones don't fail, but you can see that these were done in the commit stage. Remember, we said that we were going to show the request ID, which operation it was, and how long it took to perform, the delta. So this was a resize that took 14 seconds. This one was some operation we didn't know what it was. So it probably had no events, or it was just some odd series of requests, or maybe it was a tail end request from a previous day or something. Those might be ones that we want to actually investigate a little further. So that could be something of interest. So here was a create start that took 16 minutes to occur. Because these are coming from Node.js, these are all going to be the same durations. We are thinking about some ways to play with Node.js to stretch these times a little bit. So we're seeing all these things, and these are always going to pass. So when we look at the output from this, we see that we had no errors on the request ID one, right? No errors on this, and no commit errors. They all went through, but we processed 32 of them. So that's good. That's what we want. 28 of them were locked, which means that happened in the other worker. So if we go back to window 3, right, then we see that 32 of them were locked, 30 of them were processed here, no errors on any of them, because the other errors were from a previous, from the other request ID stuff. So that's this is a short video. This is the two-phase commit for idempotent operations in the pipeline processing, and how it integrates with the debugger, so you can find out what's happening in here. Okay, stay tuned. We're going to talk about the API and the REST interface and client tools in our next video. Thanks. Always put comments at the bottom of the video. Cheers.